Hello to viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about fixing global warming gradually part 4. This is an ongoing series. So today we're going to focus on solar puppy. So let's dive deep into it. Now, what exactly is the reason here? What exactly is the problem? Well, problem is that growth of a civilization, it does not matter which country, county, state, religion, whatever you are talking about. As long as you are talking about civilization, its growth is directly proportional to the energy that they are consuming. Like, how do we know that life is not that awesome in basically in North Korea? Well, energy consumption is almost zero. So that's how we know. Trust me, like energy consumption is one of the easiest factors that you can utilize. Now, we do need energy. Energy is not optional, it's not a luxury product, it is compulsory. However, it comes with a package deal, and the problem with that package is the byproduct is CO2. Yeah, we cannot use it in long term. For example, can we use coal industry, oil industry, all that jazz to build up our infrastructure? Yes. Can we sustain it long term? Hell no. So that's one of those things that is like this we have to look into as Mark 1 technology. It was like, yeah, it was good. Like how we had started with Telegram, now we have fiber optic. So it's the same thing. It's like we started with this, but we have to let it go for long term survivability. If we keep doing this for next 20 to 30 years, there is a very serious chance that we may reach what we call runaway effect. Once we have runaway effect, because once enough ice has melted, enough biomass degrades, yeah, methane, that's a runaway. The moment we reach into methane runaway sector, yeah, bad time. So fundamentally, it's not long-term sustainable for us. And 30% of this hassle comes from energy production. Now, generally, that percentage do change year over year and things of that nature. Now, I'm like, wait a minute, that's 30%. Where else everything else is coming from? Well, everything else is generally coming from transportation sector and basically enterprise industry, those sort of puppy. But energy production only accounts 30%. Even I was shocked that was that little. But you get the point. So this is something that we really have to take care of. And one thing you have to understand, energy efficiency, improving all of that, that sounds good and that is genuinely awesome, but we really need cheap and abundant amount of it. For example, like you take example of India and China. How the heck China got so much manufacturing capability? India could also, and be mindful, India has very large market capacity, as in like we consume a lot. So why don't we have companies making here and shipping us? Like why the heck we have companies that are making things in China, then shipping it here and then selling it here? It's like simply because we did not have electricity. Like on early stages of India, we really did not have like electricity taken care of. So that created an issue. So you have to understand, from a national point of view, you always want cheap electricity and abundant amount of it. You cannot be like, hey, our electricity is cheap, but you really can't draw megawatts of power out of it. It has to be cheap and it has to be abundant. We need GG amounts of it. So how about solar? Now solar, thankfully, it's one of the most stable technology that we are talking about, because it has reached what we call maturity, meaning almost all vectors have reached self-sufficiency, meaning all the R&D that is going on, it's going on privately. All the employment, large-scale deployment, all of them are privately done. Government is helping in terms of assistance, but it's not mandatory anymore. And many commercial, they don't even get subsidies and all that, but they still do it because it's just cost effective. We have reached maturity. That's awesome. And it's one of the cheapest source of power in multiple places. Now be mindful, not every place, it still has some place dependence. For example, in India, awesome, but let's say you live in UK and you may live in a very weird part where you have way too much fog, way too much rain, majority of your year. At that point in time, of course, the ROI, return on investment, would be very horrible in your location versus in my location. So it's one of those things you do have to understand. Solar is cheap, yes, location dependent. As in, like, so is solar cheap for Indians? Absolutely, flat out. We have reached a point, because if you go back to my birth, for example, let's say 1993, and you connect to any electrical officials, it's like, yeah, electricity, my department, I deal with it, and talk to them, is like, India is gonna have 2 gigawatt solar farm, that is a singular unit that is producing 2 gigawatt of energy, electrical energy. They would like, dude, who is your supplier, man? I need that. But here's the deal, we have this. So that part is taken care of. And many other places, be it South Africa, things of that nature, people are going YOLO on solar. So why? It's cheaper. Now there is another aspect of it. It's time tested for 30 plus years, meaning we have gone through the trial and error phase. We got this. And what does this mean? This simply means we know for a fact what is the CO2 emission of it, because you cannot make things out of magic, right? You have to make things out of consuming energy, then you make things. So you take a solar panel, you make that puppy, everything that it consumes, for example, the panel, the inverter, the power supply, all that, just basically you create X amount of emission to create the panel. Okay, how much is the lifespan of the panel? Again, early panels were very horrible. They were barely lasting 10 years. Then we researched, developed it. Now they started lasting 15 years. Now we have panels that have warranties of 25 years. So we have reached a saturation point where it's like, this is as good as it's gonna be for mass of the audience. Okay, now how much unit of electricity is gonna create throughout its lifetime? You take that. So unit of emission, unit of energy is like Y, and CO2 emission is X. Now here's the comparative diagram for that. So wind very low, solar very low. Like basically, if you are producing a certain amount of 1 gigawatt hour of unit, you are talking about around 5 tons of CO2 would be emitted from solar. Wind 4 tons, nuclear 3 tons. Now nuclear is not an energy source that I trust in the long term simply because it suffers one of those weird thing where it's like it keeps getting more and more expensive. Why? Nuclear requires a very strict safety guidelines. Can we make it? Absolutely. Can you afford to pay the staff to keep updating them, keep upgrading them, keep retraining them for safety measures? Yeah, that slowly over time your power bill starts to creep up. If it does not creep up, you reach a point where you are no longer training your staff adequately. So that's a very dangerous thing. And be mindful, every opponent of your country, so basically Russia would love if whole of Europe is powered by nuclear. Why? Then they can boom those nuclear power plants and that's your hassle to deal with. So from an enemy war point of view, that's also nuclear is really not that good. So I'm not going to talk about nuclear. Hydropower, again, it does have very high CO2 emission. Now you're like, why the heck it has such a high CO2 emission? Well, removing the side effect of it destroying rivers, removing the side effect of it annihilates biodiversities and ecology, it does require concrete, and not a few grams of concrete. I'm talking gigatons of concrete. So that puppy consumes enough CO2 that is like, let's not talk about that. So that's why it's high. Biomass. Inherently, this puppy is supposed to be around 0, but we are in early phases. We have not fine-tuned this puppy. But over time, I can easily see this puppy to going to almost 0. Not now, but I can see that. Natural gas, much lower compared to coal and oil, but still 490 tons. Oil, 720 tons. Coal, 820 tons. So that's the reality of it. Does making solar panel have emissions? Absolutely. Does it have compared to anything else? Hell no. Like wind also has the consequence that it requires a very serious amount of capital to get even started. Solar, every Tom, Dick and Harry can do, and that's why I give an example of South Africa. Every Tom, Dick and Harry is doing it. So solar has reached maturity. At this point in time, is there any renewable that actually has the power to take care of the world? Solar is one of those things. It's like, I got this. It's absolutely mature, it's absolutely stable, absolutely time tested. So the biggest hurdle that we have right now is we do not have enough of it deployed, right? We got the solar panel. Now, of course, primary reason for why don't we have too much large solar farm deployment is because of the grid. I have talked about this in last episodes, basically. And that's the reason. Even if we have a location, hey, there's this desert, just put solar farm there. People want to do that, then they're like, yeah, electrical communication is like, bro, we do not have a link there that can absorb that kind of power. But rooftop gives us a very good opportunity because it's a very untapped potential. So this is something that we really have to utilize. For example, this is Indian Railway, as in like we have hundreds of platforms, like hundreds and thousands of platforms, like ludicrously large number of platforms. Each platform have very large number of shades. If we start putting solar farm on top of them, yeah, we are talking about some serious gigawatts of energy, like serious. And I am serious about the gigawatt part. I'm not okay. It's that huge. So we're gonna get a lot of energy. Like we have not really milked our schools and warehouses. Like schools, majority of the schools are generally very flat kind of structure. They're like they have very large roof space, so we can really milk this puppy. Warehouses, they are just flat. Generally, warehouse is one of those structure that I can guarantee is never ever tall in terms of aspect ratio. It's always like short and stubby but huge surface area. And what does surface area loves? Solar panels. Put solar panel there. So, and be mindful, there are many locations around the world where you could be in a good place, good country, or you could have a good railway communication and all that jazz is awesome for you. But here's the, you may not have electricity connection. For example, Boca Chica, SpaceX, it did not have good electrical connection. They were running on solar farm and then they were running on generators and then they built a generator power plant. And then only now, recently, they are getting a full high voltage power line built for them, which is 3-phase. So it's one of those things that you have to understand. We really want to reach what we call off-grid in multiple places. Thankfully, solar in India can actually do that. Now, look, what about power, batteries and all that? It can be done for small, unless you're talking about hundreds of megawatt, it can be done. You're talking about anything that is in kilowatts, it can be done today. And I'm talking about cost effectively. So it's one of those things that can be done. And what about solar rooftop for homes? It has secondary benefits. For example, shading, meaning if Indian roofs are flat, but solar panel have to be in angle. So most of the time we build a false ceiling, then we false roof, so to say, false roof, and then we put solar panel on top of that. That casts a shadow. That is a very good thing for us, especially people who are living in the upper floors. Ground floor is kind of cool. Like in my case, my ground floor, this is the ground floor. It's kind of cool. Top floor, in summer, this summer it was brutal, as in like the walls were hot. So if we had just a false shade, nothing more than just the goddamn shade, that would have saved a lot of temperature hassle. So solar gives us that, and it lowers the cost of living. This is one of the only things that I know for factual detail, where it's like, yeah, invest in it, the ROI will happen soon if done correctly, and then for few years after that, after ROI, you have very lower cost of living. Like nowadays, because of summers are getting so brutal, we have to have what we call basically air condition. Without it, simply I specified like inside temperature is around 35 degrees Celsius, crossing more than that. So we have to have it. In those sort of scenario, the electricity bill will keep going up. So solar is the only thing that we know factually that if you do it, it reduces your cost of living. And many businesses are going YOLO on it. This is one of the things that we have to really encourage. We have to get this thing done. So we also have to look into some upgrades, that things that we have to do to make sure this puppy lasts long term. One of the first thing is we have to create better robotics for cleaning these panels, because it does not matter which is the technology that is behind the glass. As long as the glass is dirty, it's equals to zero. So we have to make sure the panels are cleaned. Now, thankfully, India has learned a lot, and these sort of robotics you will see in every large Indian solar farm, where you have waterless cleaning. These are the small ones that are built specifically for rooftop solar. So all of these can robotically keep cleaning yours. Some uses water, some are dry. That's up to you. Like you can select it. So we really have to improve this. Only then we can, like, yeah, we have a 2 gigawatt solar farm. That actually means it's actually giving 2 gigawatts. It's not like year one everything was awesome, year two it went half, and then after that it's even less. No sir, we are actually cleaning it regularly, automated, and be mindful it has to be automated. Otherwise this will also create the same paradox where it's like cost of running it keeps going up, because again you have to keep paying your employees more to compensate for inflation. So roboticizing it is compulsory. So that is the first vector that we have to take care of. Another thing that we have to do, especially in the places that are closer to equator, for example India, is that we have to jump into what we call photovoltaic thermal hybrid. Meaning these panels, they are awesome, but they have a weakness. They do not like heat. So you may think, hey, solar panel, lot of sunlight equals good. No, equals bad. Why? Because it heats up. The cell itself could easily reach 100 degrees Celsius or even hotter than that. And yes, that is brutal temperature. And if you have ever looked into any of these panels, the back panel, there is a stamp there. There's like what kind of energy you can expect. Yeah, it has stupidity, as in like 25 degrees Celsius. Yeah, no. And if you ever wonder why the heck no farm, no matter which solar rooftop you have, it's like, hey, the panel power is supposed to be this much, we never get this much. That's the reason for it. They are always tested at stupid temperature of 25 degrees Celsius. Now this, I blame Indian government. Indian government should be like, hey, you're selling panels in India, put that 25 to 50 degrees Celsius. So that is failure of Indian government. Now be mindful, it's not like some companies are trying to exploit it. It's the limitation of silicon itself. But that being said, that limitation would be there in no matter what we do. Even if we have basically multi-junction solar cells, one of which was, not one of which, as in like the variant of which was used in solar Parker probe that went almost kissing the sun, it still needed cooling. Otherwise, it would have been dead on arrival. So we need cooling. We have learned this the hard way, that panels only work well when they are cool. So how can we cool it? Well, panels manufacturing, we got it. There is this technology known as roll bonded thermal heat exchanger. Now these are huge, as in like freaking huge. How huge? Your refrigerator generally has this. So we have figured that part out. It is mass produced, manufactured everywhere, even in India, and size actually matches the size of a panel. Now ideally what you will have is PV glazing glass layer, then the PV cells, actual silicon layer, and then you will have EVA grease, the grease to make sure the electrons do not do fancy stuff. Then you will have electrical insulation, and then you have roll bonded panels. So that way the cells heat up, the heat transfers into the heat exchanger. Heat exchanger dumps that heat into your water, and voila, the panels are cooler. Now the roof area, like something, let's say, that says, hey, this is a 10 kilowatt array, that means it's gonna give you 10 kilowatt because the panels are cool. And this also has secondary benefit, one of which is like your panel will last much longer. So every year you lose around 1% of capacity. That degradation will be slowed down drastically if you can keep your panel cool. So that's something that we have to do. As India gets hotter and hotter, we have to do that, because all our panels will reach a point where our ROI, as in return on investment, will go to zero. So we have to cool this. Like, this is a place vector of research that I have not seen too much interest, but we have to. This is like long term, we have to. And the issue with that is like we have to find a way to use low quality heat, especially in summer. That's the issue. Now for European people, they're like, shut up, take money. This is awesome. I need hot water. I need home heating and all that. They're going YOLO on it. That's awesome. But for India, it's like, there are some places where they're like, shut up, take money right now. For example, hospitals, they need to use hot water to wash their daily clothes for sterilization reason. Again, they're like, shut up, take money. Awesome. Same goes for many other places. But here's the deal. What about average household? That's the place where we are like, what the hell are we gonna do with that heat? Because it's not that hot. It's not gonna be like, even though cell itself could be 70, 80 degrees Celsius, it does not mean you can actually extract that kind of heat out of it. And once you actually start to cool it down, it won't go that hot. And again, you don't want to go, want it to go so hot. So let's say same surface area, you had a solar water heater, you will get 80 degrees Celsius. You same area, you have solar PV panel and this. Of course, at ideal scenario, you'll only lose 20%. Realistically, you will lose 30%. But you will still get a lot of heat. But problem is like getting amps without the voltage. So that is an issue. Can we run air conditioner on that heat? Absolutely. It's just that it won't be very efficient. A air conditioner that runs a thermal system requires very huge temperature delta between the ambient and the hot input. For example, if you had 150 degrees Celsius hot water, awesome, pressurized water obviously. At that point in time, you can run a 100-ton air conditioning unit of it. It's a common thing. Vapor-based absorption chiller, they love to run on hot water, but it needs to be hot. This is not hot. So that's the problem. That low quality heat, we have to do something with that. Something that is not super duper expensive, something that is useful to majority of people. Now some places, shut up, take money, but majority of places, not so. So that's the part where we have to do R&D right now. And then one of the issue is that we really have not figured out how to do recycling. It's almost like when we had lead acid battery, we had the battery, it's awesome, everything is fine, then we used it, and then it's like started to contaminate our groundwater, and then they're like, yeah, we really have to recycle these. So we figured that part out. Same way we have to figure out what to do with solar panel once they are done. So these are the core principal innovation that we have to do right now. And again, I have seen people, again, this is not done by me, I've seen somebody is like, this is quite awesome, but let's see how do we go there. These are the upgrades that I expect to see in next 5 to 10 years. Now, are there some danger to solar industry? Absolutely. Now, there are way too many brain damage projects, and I do not mean that as a joke or exaggeration. I mean flat out brain damage projects, and the consequence of that is not only it burns public money, it also harms the public perception. And that public perception of solar, if it gets compromised, people will not invest in it. That has a feedback loop where solar, it could become awesome, but it will not become awesome. So that's a very serious hassle for us and a hazard for like our future renewables. So fundamentally, this is bad. Now, I'll give you a small example. Like, this was my stupidity. Even I fell into this brain damage. Solar Roadway, this puppy. I was in a job as a 3D game artist when this happened, and I was like, oh, this is awesome, this will save us. And then real life hit, mathematics hit. It was like, this puppy, it took $2 million from GoFundMe. It took $2 million from basically one government agency, and reasonably sure it took multiple millions from here and there and all that jazz. And still, they are still trolling people along. It's like, yeah, we are working on it. It's like, dude, you made a small patio that no car driver drove over, and it got busted in few months. Not even month. I'm pretty sure the first damage happened in like few days. It's like, how the heck people fell for this? It's like, again, I fell for this when I was done. But like, how the heck government agencies that have bureaucrats, not elected official, bureaucrats who are supposed to be educated, who has to go through all the trials and tribulation, how the heck they fell for it? That's the most scary part to me. Now, you would think like this was one company. No. China burnt money on this. It's like, we're gonna do solar roadways. Like, what is your weed, man? Like, who is selling you this weed? Then France is like, we're gonna do this. It's like, are you kidding me? Like, are you freaking kidding me? Like, you actually did that. Oh yes, they actually did it. They actually took millions of dollars and like, whoosh, burnt it. They actually did, not even joking. And I'm actually worried that there is some people are suggesting me that somebody in Mumbai, as in one place of India, did this. And I do not want to research it. I do not want to believe that Indians could be this dumb. Like, this happened. Like, this burnt millions of dollars and people are just not learning from it. It's like, hey, no, we have experience. At this point, we have experience. It's like, no. So that's solar roadway. That burnt millions of dollars. And then we have solar freaking railway. I just saw this few months ago from EEVblog, and I was like, yeah, nobody could be this dumb. Come on, nobody. And today I just found out that, yeah, it's getting funded by Swedish government. It's like nobody ever told them like solar panels do not like high vibrations. Which has high vibrations? Railway tracks. It's like, and again, panels love to face the sun. Here it is flat and there is a very good chance it's shading itself. It's like, how the heck you are causing, either you have an aura of brain damage where you just go to places and you are brain damaging people where it's like, oh, give me money. It's like, how the heck this happened? How the heck this project is getting public funding? Let me be very clear. If you are wasting your money and GoFundMe and Kickstarter and all that, of course, still has bad effects, but that's kind of on you. But government money, government bureaucrat is giving it green light, that scares me to my soul. Because again, this will be done, then it will fail, and then people are like, solar. It's like, and here's the location, it has a railway station. Railway station has a shading. Put solar panel on top of that. How about that? How about that? Put solar panel there. It's like, one person wrote a very amazing comment. It's like, entire humanity has this bug up its ass where it's like, we're gonna put solar panel where it should not be put rather than putting it somewhere where it can be put. For example, parking spots, warehouse roofs, railway station roofs, all that jazz, basically all the free space where you can put it, get energy, don't even think about it. Rather than that, it's like, what if we put solar panel under the road? What if we put solar panel under the train? It's like, what if you put the solar panel in the underground? It's like, why do we have this kind of brain damage? That genuinely scares me. And yes, these things are burning millions of dollars. Here's the problem with that. If you took that millions of dollars, put it into a normal basic farm, maybe let's say a parking spot that is solar shaded, that's awesome. Rooftop, something, whatever have you would have actually got a return on investment, meaning the government money was like, hey, we actually sold more electricity than that. But no, we have to just take the money and it's like, whoosh. And people genuinely fell for it. And current trend, again, this is current trend in USA. The first time I heard about this was in Australia, is that solar roof creates economic disparity, meaning this is a tool that makes rich people richer and poor people poorer. Is there a truth to that? No. Now, like, why? If people are using solar panel, they're not paying the electrical bill, but the grid still requires maintenance. Here's the deal. When grid was built, somebody had brain. I know it's very shocking. Somebody had brain. They created an ecosystem where there's like the electrical bill, no matter which country you are living in, generally have two segments. Segment number one, fixed cost, meaning they know whether you are consuming electricity or don't consume, or go for Bahamas in like fucking 2-month holiday, you're still consuming structure. As in, there's still poles, still transformer, and again, they will require maintenance. There are people, again, that's why the electricity bill has two segments. Second segment is how much electricity you consume. Solar is inherently like, hey, I'm not consuming as much. And what about like selling electricity back? Here's the, most people don't want to sell back because, again, if they buy at 1, they sell at 0.1. That's the fact. That's the real fact. That's why nobody wants to actually sell electricity. And again, from an economics point of view, if let's say they have a county and all of that county is like, producing rooftop solar. So in peak summertime, peak afternoon, you will have way too much surplus power. Here's the, that surplus power goes into the grid. What does that mean? That simply means you are not buying that much energy from coal power plants, from hydro dams. And yes, hydro dam do have a dam valves which allows them to control it. So yes, they can also control it. Every place where you have a throttle, those throttle go down, meaning you save energy, you save pollution, you actually save money on your bill, because again, that prices, but thanks to Putin, it will keep going up. So what the hell are you going to do? But here's, if everybody did rooftop solar, during afternoon, you're like, hey, we'll save money. And this also puts pressure on them where it's like, hey, actually we have to upgrade our system. We have to actually improve the efficiency of our plant. Efficiency, critical word is efficiency. You can have a lot of efficiency gain in old coal power plants. Nobody is doing it because again, companies are like, hey, who else are you going to buy it from? And they can, if they have this sort of attitude, they can just say, oh, coal is getting more expensive. It's like, why are you not developing better tools to make it more efficient? It's like, nah, what else you want to, Solar allows them to people to be like, hey, your electricity, I can't afford this. Solar, one-time painful thing. ROI happens in 5 to 8 years, especially in places that have very high electricity bill. ROI is like 5 years or even closer than that. At that point in time, it's like, shut up, take money. I'm gonna get this one punch done, and people are doing it. But companies are like, dude, what about my vacation in Russia? What about my fifth yacht? It's like, how about you invest into it? How about you improve the efficiency? So there is some serious danger, like this sort of projects will cause, this sort of rhetoric will cause. That is truly scary to me. But let's see what happens to humanity. But again, this is amazing tool. This does allow to, this is the biggest sword that we have to fight global warming. So this was my presentation on basically how do we fix global warming gradually, part 4. Hopefully you have liked it, learn from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.